Okay, hello everyone. So this is going to be the first video in for the actual programming stuff for some Python game programming. To start, this video series is geared towards kids, and so for you more experienced programmers out there, you might see me write code in certain ways that's a little bit different, but that's just due to the nature of how or the audience for these videos. That being said, I will try to generally teach what I think are good programming practices, because I think that's important for kids to be able to learn. Anyway, to start, in order to actually do programming, you'll need to make sure you have Python installed and then the Pygame library. I'm not going to show how to go over that in this video, but it's fairly easy to get Python installed, and then I have another video out there that shows a little bit about how to install Pygame. But anyway, if you do need Python installed, you can go to python.org, go to downloads, and then it should be able to download Python for whatever operating system you currently are using, Windows, Mac. Linux is a little trickier, but I don't think most people will be using Linux for this, or if they are, Python's probably already installed. And then Pygame can be found from pygame.org, and then you run this pip install pygame command once you have Python and pip installed. Anyway, so for the most part, I'm not going to assume any real prior programming experience for any kids watching this. You do need to be able to read and type on a computer, and probably have some basic understanding of math. But beyond that, I'm going to largely assume nothing. But we may not go into all the details of exactly how programming works from the start, but we'll gradually fill in that information. So anyway, the goal for this session is to basically get a window on screen with a background color using Pygame, and so that's what we're going to do. To start that, I'm going to open up idle, which is the editor that kind of comes, editor and development environment that comes with Python, just because it's easiest to use and should be available for basically everyone. So to start, I guess I'll cover a little bit of what this window is for those of you who are completely new to programming. So Python comes with this idle program, which if you look here, it stands for Python's Integrated Development Environment, and that's basically what it does. It gives you sort of this shell window to start, which is a way for you to type in some very basic commands one line at a time and have Python evaluate the values and display the results. So for example, I can do a print statement in Python, which is pretty simple. Type print, and then since I'm calling a function, there's that opening parentheses, and I do either single quotes or double quotes on my keyboard to start a string value that I want to print. Then I can just type some arbitrary text, close the single quotes and close the parentheses, press enter, and you'll see Python evaluates that code and prints out the results in this little shell. So this is a pretty good way to just test out one-line commands. If I want to do some math, I can do that, and Python will evaluate it as well. Also, if you want to get help on some basic built-in functions and other things, you can type help and Python will print out some help here. So just a little interesting thing you can do. Now, so other than the shell, Python provides a way for you to write files for your programs, which is kind of necessary to have any significant program that's more than these single line things that you type here in the shell. So I'm opening up a new file here, and I'm going to switch the sides of my screen. These are on so that y'all can see this better. So once I have a new file here, this is where we're going to start typing in our code. So code for is basically just a bunch of instructions or statements that tell a computer what to do. They're generally written in human readable language similar to English in order to help us as humans understand it, and then when we run our programs or compile them, they're converted to a form that our computers understand, and so that they're able to execute our programs. So from a bit of a conceptual perspective, if what we wanted to do was open up a window and display some text on the screen, what we might want to conceptually write as instructions are something like open window, and then the next thing we would do is give the computer some instructions like display hello in window. Now this isn't valid Python code, so if I were to try and run it, it's going to error out on me. But it illustrates some important principles. So in programming, typically we have multiple lines of code. So if I wanted to display some other text and then close my window, I would need to type some very precise instructions to do that. And the way our programs execute is they would typically run line by line. So if I were to run this program, assuming it was a valid program, it would execute things exactly in the order that I have specified here. So it would go execute this first line, open the window, then it would go execute the second line, display hello in the window, and then it would go to the instruction on this next line, display world, and then finally it would go display, it would execute this close window instruction, if that existed. So that's a little bit of an overview of what programming is like. It executes the instructions, or the computer executes these instructions that you give it line by line, essentially, in a sequential order. So now we're going to write our actual program. To start, I'm going to go ahead and save our program here to a file. And this is just to go ahead and have our program ready to be saved, and so we don't lose any of our work. It'll store it in a permanent location on our computer. I'm going to give this file a name, basic Pygame example, because that sort of describes what it is. You can theoretically name it just about whatever you want, but it's good to name them after what they contain so you can remember later. So once that's done, I have my file, blank file, initially saved, and so let's get to programming. So in order to use this Pygame library, we first need to actually import it into our program so that we can use it. So Pygame as a library is sort of a collection of a bunch of code that someone else has written to help us more easily do sort of game programming thing. And so we want to use that in our program. We have to import it to make it available. So that's done with Pygame by this import Pygame statement. So next, in order to actually start using Pygame, we're going to need to initialize it or do some initial setup to get it ready to be used. Now, because this program is going to get pretty large eventually, I'm going to insert what's known as a comment, which is sort of just a note to me, the programmer, sort of what I'm doing. And I want to describe sort of these major steps in my program so that I can easily find and jump to the steps later. Now, comments aren't actual like statements that execute and have any effect when your program runs. And therefore you can sort of insert whatever you want as notes to yourself or others who could be reading your code later. In Python, comments are indicated by starting with a number sign or a pound sign or a hash mark, depending on your background and what you call it. But you basically press Shift 3 on the computer and you'll get this sign here. And I'm going to write a comment that indicates that what I'm going to want my code to do is initialize Pygame. And the way we do that is by typing pygame.init, which is a function or some grouping of code in Pygame that will get executed. Now, once that's done, just to show you what goes on so far, I'm going to save my program. And then to run it, I can do run module here. Sorry, my mouse is acting a bit up here. So if I do run module, and then you look over here, the shell will give you some indication of when your program is running. Now, as you can see, our program hasn't done anything so far. And that's because the instructions we've given over here don't really do anything that would be visible to us. And so that's why our program just kind of exits here and doesn't do anything that we see. So now what we're going to want to do is create our window that's going to hold our game screen where we are going to display all of our graphics and things that we do. So in order to do that, I'm going to add another comment here that summarizes kind of what we want our program to do next, and we're going to create the game screen. So our screen is going to be a certain size, and I'm going to create some variables to hold the size of the screen we want. So I want my screen width to be a certain value, and I'm going to just arbitrarily choose 400 for now. And I want my screen height to be independently changeable too, so if I want a different height than my width, I can change that separately, but for now I'm just going to pick 400. Now, so a couple of things about what I've done here. So I have done what's create a variable in Python, and I do that by giving it a name, which can consist of any sort of letters A through Z. They can be uppercase or lowercase. It can consist of underscores, which you get by pressing Shift and then like the dash or hyphen on your keyboard. And they can also contain numbers, but you can't actually start a variable name with a number, so this would be invalid. But they can't contain spaces or any other characters like that. The other thing is, after I sort of give the name for the variable that I'm creating, I need to give it a value of some kind. Because a variable is essentially a named storage location in a computer's memory, and we want to fill that with a value that we can use later in our program. So we say we're going to give a variable value by using this equal sign, which indicates assignment. We want to assign a value to this variable. And the value we want to assign is the value on the right side of this equal sign. So this line here is saying that I want to take the value 400 and I want to assign it or store it in a variable, which is a location in the computer's memory, that I want to label or name screen width in pixels. So now a little bit of a programming style thing. So often in programming we have variables that will we want to have hold values that we don't necessarily want to have changed when our program is running. Those are what we typically refer to as constants. And then actual variables, which we might want to have their value vary, which is where the name comes from. Those are values we could change later in our program. So, for example, if I had a player position that I assign to some value here, and we'll just say it's the X position along the X horizontal axis, and then later I wanted to increment that variable in my program by adding a value to it, then I can do something like this. And so after this line of code executes, player position would have 30 because 10 plus 20 is 30. Now, to help me as a reader understand what values I might want to have changed and what values I don't want to have changed, I typically use a different naming style for my constants as opposed to my regular variables. So for constants, I typically use all capital letters separated by underscores, and then for just regular variables, I use lowercase letters separated with underscores separating the different words. And so what that means is it helps me later in my program differentiate if there might be an error that I didn't intend. So if I have this code here that's modifying player position, that's fine, that's valid, because I see these lowercase letters communicate to me that it's okay to change this variable. Now, if I later in my program had something like this, that would signify to me an error in my program. It's doing something I probably didn't intend because I have full capital letters here, which is indicating a constant, something that shouldn't change after I give it an initial value. And then what I'm doing is I'm changing it by adding to it 40. And so that would signify an error in my program based on what I want it to do, and so I should think about correcting that later. So last thing I've done with these names is I've added the units in the variable names, which is something I've found to be very helpful for preventing errors, because it's very easy to mix up units when programming. For example, if you have a variable that's holding feet, as in like the measurement, and then you have another variable that's holding inches, if you try to add those two links together and they're just storing raw numbers, then that doesn't really make sense in a program, and that could be a cause for errors. But if you include the units in your variable name, so for example, length in feet equals, I don't know, say 3 feet, and then we have another length in inches, which we'll say is 7, then if I have some code like this, which is intended to take length in feet and then add length in inches to it, this is sort of very clearly an error. It doesn't make sense to directly add inches to feet and then expect a value that comes out in feet to make sense. And so that would suggest to me that I need to change this to feet, and then I would need to multiply this by 12, and so I could do that by that, like that. And so that's just a sort of defensive programming practice that I've found is helpful. Now, what is a pixel? If you're not familiar with it, a pixel stands for picture element. And so there's this wonderful Wikipedia page you can see here. But I'm going to actually open up Microsoft Paint to give you a little bit of a closer idea. So on our computer screens, you can think of them as having a lot of dots or very tiny little squares that make up the image we see. So, for example, here, if I zoom in real quick, you can look here and see all these little tiny squares here. And you can think of each one of them as a pixel that I could, fill in with a different color if I wanted to. And so that's how we basically get all these wonderful images and things displayed on our computer screens. So that's all we'll talk about for pixels for now. You can think of them as these little squares. So back to our program. So the thing that we're going to do now finally is actually create our window. And we do that with a function that's built into Pygame. And so within Pygame there's this sort of display module, which is sort of another grouping of things within Pygame. And then we call the setMode function in it. And you can see here how setMode takes a number of different parameters. For now, we want to just pass the screen width and the screen height, which corresponds to our resolution that you can see here. And you'll see it needs to be in parentheses here, which is what is known as a tuple in Python. And so we'll just pass our width and then our height in pixels here. And then finally, we'll want to actually reference our screen later in our program and do things with it. And so I want to store the value that Python returns from this function that it gives us back in a variable. And that variable is going to be our game screen. So I'm going to call it screen and store it like that. So what is a screen? Well, I want to go ahead and mention that an important thing in programming is being able to read and reference sort of this official documentation that might be available for whatever library you're using. So Pygame has this documentation here online, and actually we'll see if the help stuff works for Pygame stuff. So if I do help pygame.display.setMode, yeah, so there's a little bit of help information here that Pygame gives us, but if you go online, you'll see more detailed documentation. So I'm looking at the display module, and there we'll look for our setMode function. And so you can see all sorts of documentation here. So it returns and gives us back what is known as a surface. So what is a surface? Well, a surface is, you can think of it sort of like a drawing surface, kind of like a piece of paper that you might draw on. And so it's something like that. It's just something for us to draw on. And so that's what Python gives us back here from the setMode function we're using. Okay, yeah, and so if you ever have any questions about Pygame or you really want to learn more about it, I definitely recommend taking some time to read through this documentation. It can be kind of hard to read at times. So you might take a lot of rereading and rereading and rereading to try and fully understand what it's talking about, but it can be helpful and is a very good skill to develop long term. So now I'm going to run our program again. I generally do not recommend running your program now at this point if you're following along at home because of what I'm about to show you. It's relatively harmless if you do, but I generally recommend not initially doing it at this point. So if I go and run my module, which I can also do with the F5 key on my keyboard, so I'm going to do that, you see that it's created this window. So that's nice. Now here's sort of the problem and why I was sort of recommending against running it right now. If I try to actually close my window, you see it doesn't close, which is kind of a problem that we need to fix. And so that's what we're going to turn our attention to next. So another thing to understand, when we have these kind of graphical windows in our programs, they typically run based on the concept of a loop, and where we want them to run until the user does something that explicitly tells us to exit, like clicking the X button up here in like the top right corner. And so we're going to want our game program to basically do the same thing. And in order to do that, I'm going to add another comment describing what we want to have happen in our code before we actually write the code. So we want to run the game until the user chooses to exit. In order to write the code for this, we're going to use what's known as a while loop. So when we have a while loop, what we can do is type while and then a condition, and then here what we can do is type a bunch of programming statements. The text I'm typing here isn't valid, but what's important to note here is that anything that's inside your while loop that you want to execute as part of the loop needs to make sure to be indented here. And so as you can see, I've pressed the tab key on my character, which has inserted 4 spaces here to indent the content of this loop that I want to be part of it. And so how does a while loop work? We'll get into this more later, but the basics are it's saying while this condition that we've specified is true, execute all of the code in the body of the loop, then go back, reevaluate this condition. If it's still true, execute this line again, and then this line, and then this line again, and so on. And then once it gets to the end, it's going to go up here and reevaluate the condition to see if it's still true. Now, because we want this game to run until the user chooses to exit, and sort of the simplest way to handle that is going to be within the body of the loop, not as part of this condition here. What I've done here is specify a condition of true, which is always going to be true. And so what I've done here is basically create an infinite loop, which would be kind of dangerous to run right now. But once we have the appropriate code written, we're going to exit out of the loop kind of with inside it, which will prevent an infinite loop from occurring. Okay. So another thing about the way these sort of graphical user interface or GUI programs work that bring up windows like our Pygame window or this window right here is that they basically work on an event-based model where anytime the user interacts with something, clicks something, for example, events get sent to our window program, and then we are responsible for writing code in our program that responds to those events and handles them appropriately. And so that's basically what we need to do in order to have our window that we had pop up just actually close. And so that's what we're going to do now. We want to handle any events sent to our game program here. And the way we do that in Python is using a for loop, which lets us kind of go through one by one a number of different items within sort of a list of items. And so we'll go over exactly how this works much later, but we want to go through for each event in the events that Pygame has received for our window. We want to get each of those. And then what we want to have happen is exit our game if the user chose to quit. So how do we do that? Well, Pygame has a bunch of events built in. So if we go here, and then trying to see. Quit. Here we go. So here you can see sort of a list of all the different events that Pygame exposes to us. You see there's a quit event, which is what we're going to want to actually use here. And there are also things for like dealing with mouse presses or keyboard presses, which we'll get into later. So going back to our program, we want to say if the event our program has received is the quit event, which we'll do by looking at event.type. An important thing to check sort of equality in a lot of programming languages such as Python, we need to have double equal sign here. A single equal sign won't work because that's used all the way up here for assignment statements. So if the event we've received is a quit event, what we'll want to do is call pygame.quit here. And so once that's done, we can save our program and run it. Now this will be another interesting thing to see. So if we try and close our program now, oops, sorry, my mouse is acting up again. Anyway, so if we have our window here and then we go to close it, you can see it closes, but if you look over here in our Python shell window, hang on. Up here you'll see, oh, there's an error here. Well, that specific error is because there's one more thing we kind of unfortunately have to do to actually exit our program with Pygame, and the exact error could vary depending on the operating system you're working on, and even the behavior might not be consistent. But basically the issue is pygame.quit doesn't fully quit our program, and so in order to do that we need to call the sys.exit function, which is part of another module that's built into Python. And so we need to call that to fully close the program. And this is a very weird thing, so I'm just typing in a comment here to explain what's going on here, since it's a sort of a tricky thing that we have to work around. Anyway, so in order to call sys.quit, we need to import the sys module, which is built into Python, so you don't have to download it or anything. And so I'm doing that at the top of our program here, since it's usually good practice to put all your import statements kind of at the top. And then now to actually exit our program, I can call sys.exit here, And then now if I've run my program again, you see my windows popped up, and then if I want to close it, assuming my mouse works, you can see now it's exited the program without giving any errors. So that's just a weird sort of workaround we have to do with the way Pygame works, but you can imagine for more advanced games you might need to do a bunch of other things here before you actually shut down your game. And so that's possibly why it's done that way. Alright, so what we're going to do now, and kind of the last major thing, is we're going to change the color that our window displays. Right now you see it's sort of just a default black color. So in order to change that, we're going to need to use some other functionality built into Pygame, but we'll also need to define what our background color is. So what we want to do is clear the screen for the new frame of our game, because the way game programs typically work is they display frames, or sort of like individual pieces of paper for an image at once, and then you recreate that image in whatever new state based on what's been moving each time through your game loop here. So anyway, to clear our screen, we'll need to define what sort of background color we want. So I'm going to create a constant for that, and in Pygame we do that by creating a color which is part of Pygame. As you can see here, it takes you can take a variety of parameters, but RGB values, which stand for red, green, and blue, are the typical way we do that. We specify colors in a lot of computer graphics. So if you're curious about pygame.color, there's plenty of documentation here. But if you're not familiar with colors and computer graphics, they typically are defined in terms of separate red, green, or blue components, which you'll often see shortened as RG and B. And these values can run from 0 to 255. So if I were to change this, all of these components to 0, you can see I have complete black. That's taken away all of the light that's part of the color we're forming. Now, if I want full white, I need to sort of increase the values for all of these color components to their maximum values, indicating maximum red, green, and blue light. If I do that, you'll see I get white. Now if I want like just pure red, I need to set the red to the maximum and then change green and blue to 0. If I want pure green, I can change just green to be the maximum value. If I want blue, then I can change blue to the maximum value. If you wanted like a middle of the road value, then you could do something like that. And then, you know, you can also mix and match a lot of these color values, which is how you get like some more interesting colors. So I'd encourage you to sort of just experiment. And if you have a paint program like this on your computer, you can easily change values to see what the colors would look like. Anyway, so our screen's already black, so temporarily I'm going to change the color here to be full red, since red comes first, RGB here. And that way we'll have something different and know if our code is working when we run it, as opposed to just having the black default. To actually clear our screen with a solid color, we're going to want to use the fill function for our surface, which is our screen. And as you can see, it's pretty simple for what we want to have happen. We just need to fill it with a solid color here. So that's basically that. Now, if we run this program now, what we should expect to see is our screen filled with red. But as you can see from me running the program now, that is not the case. It's still black. So why is that? Well, let me go grab a couple pieces of paper and I'll be right back. Okay, so the way things work a lot of the time in computer graphics is our screens, our displays are what is known as double buffered. And what that means is that the sort of screen that you see on your laptop monitor or whatever isn't necessarily what you're drawing to immediately. So there's actually sort of two screens. One of them is sort of a hidden surface, a hidden buffer that's in the background, whereas you have another thing that's actually what's being displayed on the monitor at a given time. And so the reason for that is if you only had one sort of surface, one piece of paper that you were drawing on, while you're doing the drawing commands, while they tend to be pretty fast, they aren't necessarily as fast as your monitor is displaying images. You would experience like what's known as screen tearing, sometimes where users could see some of your drawing operations before they're completed. So for example, if we didn't have a sort of this back buffered scenario, someone might see our screen in our window half filled with red at this point. And so what we need to do is have this back buffer system, and the way it works is you can think of it as having like one piece of paper which is currently being displayed to a user, and then sort of behind that you have your separate hidden surface. And then when you are telling your program to do all these draw commands like screen.fill, it's actually drawing to this hidden surface behind what's being displayed to the screen. And then when we're done with our drawing commands, we need to tell it to sort of switch these surfaces and what's being displayed to the user. And so when we're done, we'd want to basically switch these around, so what we were drawing to becomes the front surface or buffer that's displayed to the user, and the back one is what we can start drawing to again. So how does this work in Pygame? Well, within pygame.display, it has an update function, which basically does this flipping of the back buffer that we were just talking about. And so to call that, we want to display the updated frame after we're done with all of our drawing and other updates to it. And so to do that, we call pygame.display.update. And now if we run our program, you should see, hey, now it's red. That's exactly what we wanted. Okay, so I'm going to change our background color to black again, because that's what we're going to want, at least initially, for our actual game that we'll be expanding upon in future videos. But that's it for this video. Now, to get a little bit more practice and familiarity with this, I have a few additional exercises, which I'll put in the comments below for this video. There are a few things you can play around with here. You can try and change the size of your window, and then you can also try, experimenting with the colors here. So that's what I'd recommend doing, and then pick up and expand upon this for the next video.